All right, so in today's most wonderful version of ENGR210L, I'm going to start with a exercise kind of plays with some of what we talked about on Friday concerning strings. Then we're going to jump into something new, essentially just another way to get input from the user. We talked about last Friday, it'd be nice if there was something besides um, load text that we could use. Thinking if I have some input file and it looks like, not like any of those, and it looks like this, say, where I've made some notes in the text file to let myself know what some of the different data points correspond to. I might not care about those notes, but I could not, but I have to work in order to pull this into load text. It'd be nice if there was just some way of pulling this file in such a way that I didn't have to care about the fact that I had notes in it. I could keep them there so that when I looked back at it, I knew what I knew what I was looking at. It'd be awfully nice if that way, if there's someone to do that existed, and there does. We just have to do a little bit, we just have to approach opening up the file in a little bit different way. So that's where we're going to go. But where we're going to start is with strings. So strings are what? What is a string besides a piece of yarn? What is a string? How do you define a string if you had to? Yeah. Okay, so what? So I want to say this. So what you're saying is something that you can do with strings, but a string is not that whole method. A string is a data type. Much like a float is a data type, right? A float's like a number with decimal places. And an int or an integer is a data type. It's a whole number, positive or negative, so it is a mathematical integer. A string is a collection of characters or an array of characters. They can be letters, numbers, punctuation marks, whatever. So that could be a string. It's just a data type that holds a particular kind of information, and that particular kind of information happens to be anticipated to be non-numeric. So we're going to try using strings on a problem that ironically has numbers in it. Anyone here ever used binary before? Thank you. Oh, this will be fun then. So binary. So binary is also known as base 2. It's another way of counting. We remarked on it being the way that computers think, because in binary, you can only have one of two values, so 1 or a 0. So in a binary number, I'm just going to write one out here. There's a binary number. Each digit can only be a 1 or a 0. The difference between binary and base 10 is, well, it's what the base is, but it's what each place value stands for. So usually this is what? The ones place, right? Or 10 to the 0 place, because it's the first place. Here it's just the 2 to the 0th place. So it's still the ones place. Great. this guy would usually be the tens place, or 10 to the first power, right? Well, now it's the 2 to the first power place, or it's the 2's place. Do you kind of see the trend in here? This is now the 2 squareds place. This is 2 to the third, 2 to the fourth, and so on and so forth. As instead of it being increasing powers of 10, it's increasing powers of 2. So it's binary, base 2. So if I was to look at the value of this number, well, there's 1, 1, there's 1, 2, no 4s, 1, 8, and 1, let's see, that's a 16, that's a 32. So that's what, 43 in base 10. How are you feeling with that? Let's do one. Let's do one more. So I'm going to start with some binary. Let's say there's some binary number. So if I was to convert that to base 10, essentially I just look at each place value. I look at how much is there and I add it all up. Okay? So how many ones do I have? Say again. Okay, that's literally how many ones. How many of the ones place do I have? Say again. 1, right? Because if I look at the ones place, there's one there. Okay, so got 1 plus. Next thing is what? What's this place value? First one was 1. The second one is 2. Right, it's 2 to the first power, and there's zero of them. So nothing there. Next, which is called the next place value, would be 2 squared, because this was, yeah, that was 2. It's 2 to the 0 to the first, 2 to the second. So now we're at 4. And there's 1 of those. Then you have 2 cubed. Got 1 of those. And then we got, right, 16, 2 to the fourth, and got 1 of those. So our base 10 value is what, 29? Cool. You all feeling comfortable with that? All right. Now we're going to write a calculator to do all that for us. So game on. All right. So let's move over to PowerShell. Sneeze again. And let's do this. And binary conversion. Okay, so get rid of that. Okay, so that's what we're here to do. Let me make that a little bit larger. I'll throw this somewhere. Make sure that I'm sharing the right screen. Great. Okay. So, want to convert a binary value to base 10. All right. So first thing I'm going to do is I'm going to ask the user to give me a binary value. Excuse me. So input a binary number. Great. All right. I'm just using the input command, so I know that I'm going to get a string. And that's fine. That's actually kind of what I want, because Python and everything else in the world works in base 10. So I want the input to be a string. Using the input function, it conveniently gives me a string. So hey, we're all set. Cool. So what do I want to do with this? Well, the logic that we had when we just converted these binary values is that we looked at each place going from the rightmost value to the leftmost value. And we said, okay, is this a 1 or a 0? Okay, if it's a 1, I add the value of the place value to my kind of running sum. If it's 0, I just add 0, right? So that's the same logic that we want to approach this with. So I want to get my string and then go through the string 1 digit at a time from right to left, and then call it, and multiply whatever's there by its place value. Cool. And the convenient part about all this too is that strings are like arrays, right? I can access each character in them. So if I was to look at this, let's see, I don't want to say this, so just kind of from the outset, I'm thinking that I want to use some sort of like a for loop. The only trick is I need to know where to start the for loop from. So I need to know the length of this string or how many characters are in it. So does anyone remember the command we used for that on Friday? Yeah. Len. That gives you how many characters are in the string. Okay. So we want to go through the string from right to left. We have a couple options for this, honestly. One is to use a for loop and set up a range. The other one is that if I put in a negative value for the address, for the index, it'll actually go through the array backwards, which is kind of cool. But we're just going to set up a convenient range. So I know that the highest index in the array, the highest address of any cell in an array will be one less than its length, right? If I have a array that's 10 elements long, it starts at 0 and its highest address will be 9. So I know that the largest address that I can look for in my array input value will be 1 less than string length. So I want to start there at string length minus 1. Cool. Where do I want to end? What address do I want to end on? Because I'm more or less just using I usually use my for loop to get array addresses to look at, right? Usually it's like a row number or something like that. Here it's the same. Here it's the same thing. I'm just going backwards through the array. So I'm going to look. So my first address is going to be my last one, the address to the far right on the array. If I was to draw it out, it might look something like this. See if I can be cool. So if the user puts in 1101, 1 as a string, chops it up by characters. My array looks like that. This guy's array address is 0, 1, 2, 3, 4. So string length minus 1. This is a 1, 2, 3, 4, 5 character long string. So I'm starting on 4. I want to go backwards like that. Means that the place that I want to end is an array address of what? 0, right? And in the syntax of the range command, it's where you start, comma, where you stop, comma, what you step by to get from where you start to where you end. So what's my step? Negative what? -1, right. Every time that I go through the loop, I decrease the value of I by 1. So here it's going to start at string length -1. It's going to go towards 0, and it's going to get there by decreasing in size by -1 at a time. But wait a second. Whenever we used the range command before, say if I did range 10, did I ever get to 10 for I in range 10? No, it never did, because it stops right before it gets to, it stops when I is that end value. So if we want to get to 0, what do we have to do here? Right, that has to be -1, has to be 1 less than where we're trying to go to. We know that this is all, we know that we're always going to end at -1. We know that we're always going to decrease the value of I by -1. The only thing that's going to change is where we start from. So we already got that one covered. So this should be set. Awesome. So just to test this out, I'm just going to print the value, the element from input value that refers to. All right. So put that Python binary convert. Okay, input a binary number. Oops, that's not a binary number. I'm going to put in that. So when it prints out, it should be 000101, right? Awesome. So that's exactly what we're looking for. All right. So we know that this code is doing what we want. We know that we can get out each digit of our binary value starting from the ones place and going up towards the highest place value. Great. All right. That's a good deal. But I don't just need the value from the binary number. I also need what the place value is, right? And I also need a variable that lets me sum all these things up. So I need to make some more numbers here. So use that to sum everything up. When I go through and figure out what place value I'm at, it's relatively straightforward. I just need to know how many place values I've looked at. If it's the first one, then it's 0. If it's the second one, then it's 1. It's 2 to the first. If it's the third one, then it's 2 to the second. If it's the fourth one, it's 2 to the third, so on and so forth, right? If I had a number that counted up 1 every time I went through the array, every time that I went through the loop, I'd be done, right? I'd have kind of the power that I need to raise 2 to in order to obtain the place value. However, my I is not doing that. It counts the opposite way, which is fine. It's what we need to do. But I need a variable that counts the other way. I need one that counts up from 0. So how would I do that? Yeah. Yep, great. So I can use that to kind of count, to keep track of what place value that I'm on. And because I'm starting at 0, my first place value is 2 to the 0. So I don't want to increment the value of x until the end of the loop. All right. So while we're here, let's grab the first value out of our input, the first binary value. Let's grab that. You said its base 10 value is just the binary value. It's either a 1 or a 0 times 2 to the x times the value of the place value. So for the first one, that should be 2 to the 0. And then our summation's just adding that converted binary value to all of our past converted values, which is what this does. So. Okay. So in theory, that should be a good thing. Any questions with this? Great. Okay, so let's run this. So I'm going to use the same number that I had before. So this is a let's see, 0, 0, 0. So that's the ones place, twos place, fours place. Got 1, 8, no 16s, and 32. So this should be 40, right? Ooh, that's not good. Ooh, that's really not good. What the heck is that? So what's going on here? What it's trying to say is, so addition's an operator, right? You have the addition operator, plus the plus sign. It's saying that it's not, it's called, it can't add an int and a string. What's an int again? Right. It says you're trying to add a number and something that's not a number. What the heck, I can't do that. How do I fix that? Yeah. Okay. What should I convert to a float? This guy here, convert that to a float? Or are you saying like back up here? Okay. Well, one way to do that is just to put a decimal place there. Now it's instantly a float. But remember, the problem was that it was a number and a thing that's a not number. So now we just have an unsupported operating for type float and string. So what I need to do is get both things in, it's referring to line 17. Specifically, it's referring to the things that are being added in line 17. So it's referring to these guys. I need them both to be the same data type. They either both have to be strings, or they both have to be ints, or they would both have to be floats, or, well, they don't both have to be floats or ints. They just have to be both numbers. You can't have one that's a string and one that's not an is not a string. So how do I convert? So which do I want to convert things to? Do I want to convert them both into strings? Or rather, better question, which one of these is a string? that's a good place to start from. To look at that, well, I can look back here. So base 10 out. If I look back up on line 8, that's a bona fide number, right? 0.0, there are no quotes there. If there aren't any quotes and there's just a number, it is a number, darn it. And it's 0.0, the only kind of number that supports, the only type of data type that supports decimals is a float. So I know beyond shadow of doubt, base 10 out is a float. If I want it to be an int, that's fine too. I can just get rid of that decimal point. Regardless, base 10 out is a number. However, let's look up here. So where does base 10 value come from? So base 10 value, line 17 comes from binary, base 10 value on line 14, which comes from binary value, which comes from line 13, which comes from input value. Input value comes from up here on line 4, from that input function. Does input give you a string or a number? String, yeah. So that means that input value is a string. If input value is a string, everything you get from it's a string. So that means that base 10 values a string. It's not a number. So that's problematic. So I could try converting base 10 out to string. Played that game before. I just have to put str, the variable I want to convert to a string in quotes. Can do that. I'll run the code 101,000. Well, that's fun. Cool. Well, remember what happens when you try to do math with strings? You can't do math with strings. When I add two strings together, I literally just take two strings and I smash them together into one big string. If I multiply a string, say if I have high times 3, if I have a string high and I multiply that by 3, I get high 3 times. Have high and I add it to itself. I take two strings and I smash them together. I can't do math with strings. It just mashes them all together or multiplies his thumbs so that there's more of them, which is what it looks like occurred. So that means converting everything to a string, not the way, not the answer. I have to convert everything to a number. And base 10 out, right now it's just base 10 out equals 0. That's how it starts. So that's an int. I expect everything else to be an integer. So I'm just going to convert this guy to an int. Question is just, where do I do it? If I do it here, oops, not that. 101, 100. Okay, that's shorter than it was, but still not what I'm looking for, right? And why is that? Why is it still weird? I converted it to an int. What the heck? I have it right there. It's a number. Number plus number should be a number, right? Why is it weird? Is there anywhere that I do math with that before I convert it? Yeah? Nope. Yeah. Okay, I see what you're saying. Not, not quite that. The answer's in where we do it. So as of here, base 10 values a string, right? And then I turn it into an integer and it adds to base 10 out, right? So up here, base 10 values a string, right? Binary values a string, right? A binary, which we call a string times a number, that's just a string multiple times, right? So whatever this was, if this was a 1, now I have, if this is like my third time through the loop, I now have 8 1s. And then down here, I convert that into an integer, so I now have 11,111,111 plus whatever was there last time, right? So the trick is, okay, sure, I converted it to a number here, but I do math with it before there. If I want to do math with it, it has to be a number in order for me to do that math. So what I'm going to do is make it a number from the very beginning. As soon as I pull that character from the input string, I make it in that right then and there. I can do whatever I want with it. Zero one, zero zero. Again, the answer should be 40. There we go. Excuse me. Any questions with this? Cool. All right. Let's put one last comment on here. All right. So that's your playtime with strings for the beginning of the class. Let's play with something more interesting. Okay, so almost there, and there we go. Okay, cool. So on Canvas, I have a file up. It's in the strings and file IO module. It's called nrel data not clean .txt. It's essentially that text file that I had up before that had extra comments. Looked something like this. So if you want to pull that down, it'll be useful for the exercise that we're going to run through. All right. So say I have something like this. Our thesis was that it'd be nice to be able to use an input file such as this, where you can add some notes for yourself, but still pull it into Python and have Python not yell at you. Especially if you don't have things that are precisely segregated, or you have an imbalanced number of values in a row. Load text won't like doing that. So let's see if we can do it with other ways. See if we can pull this in some other way, shape, or form. So here we go. All right, so what we're going to do is similar to what we did to write data, except we're going to read with it. So instead of using load text or this input statement, what we're going to do is we're going to read a file. So we've used the open statement before to write. Now we're going to use it to read. And what changes is instead of the file name comma quotes W, it's file name comma quotes R, or read. I forget which one's the default, or if you don't include that, if it's read write, I just include it so that I know what I'm doing. So let's play. So let's play this game here a little bit. Oh, I need to close you out. Wait for it. Almost there. Wait for it. And there we go. Okay. And I do have it in this folder. Sweet. Okay. Okay. So I'm going to call this reading from a non-clean text file. So the first thing I have to do is open the file. Oops. Put exactly the name of the file there. And I'm open it to read. Just make sure I spelled it right. NREL data not clean. My D is capitalized. Okay. So when I open a file like this, the kind of cool thing about Python is that, well, you can iterate through anything. We've iterated through numbers. We've shown at least one example of iterating through a string. I can say for I in quotes Python, and it'll go through every single element in it in Python. If I did that on an array, it would go through all the elements of the array. If I do that for a file, it goes through all the rows of the file. So I can say something like that. And I will take on the value of every single row in the file. So if I say print I, let's run that. There's every single row in the file one at a time, right? Sweet stuff. Just don't do what I did when I forgot to close it. Make sure to do that. So to be a little bit more clear, I'm not going to call that I'm going to call it rows. Excuse me. But the thing is that I don't want the entire row. I want parts of the row, right? So this is where we call the command we talked about on Friday is going to come in handy, rather the split command. We want to split up that row, which is a string, into its individual parts. So I'm going to come up with another variable, call it row data. And I'm going to call it, I'm going to save in it however that row gets split up. So let's have a look at that. So I'm going to split the row based on the default is white space, so spaces, tabs, all that sort of stuff. I'm going to see how that splits up my data. So that's kind of cool. Remember, wherever there are square brackets, it's either an array or, to be more specific here, a list. A list is just an array of strings, pretty much. And everything in quotes is an individual string separated by commas. So this is the first element in the array. This is the second element in the array. First, second, third, fourth, fifth, sixth. But it can, which call hold. So I don't necessarily have the same size string in every row, and that's fine, because only some rows have comments in them. But this is what's called wind speed and power output for wind turbine, right? The first column is always my wind speed. The second column is always my output power, right? So I know where to find them in every array. I'm looking for, if this is my array, this fifth one down here, 347 £, cut-in speed. What elements do I want out of this if all I want is my wind speed and my power? What are the array addresses that I want out of that? Everything goes from left to right too, so it starts on the left, ends on the right. If this guy's my array, the first element's on the far left. The array is called, and that also happens to be my wind speed. So that address would be what? It's the first array element. 0, right? Second element's my power. Addresses 1. So I always want, regardless of if it's this kind of long list or a 2-element list, I always want the data in addresses 0 and 1, always, because that's where my data is. So I kind of know what's going on there. I also know that the first 2 lines of the file are just header stuff, so I want to skip those. So I want to skip 2 rows and then read the first element, then the second element from everything in-house. Cool, cool. Or rather, let's try to be a little bit more specific. Let's just say we're going to try to compute power based on wind speed. We've done that before. Let's do it again. So I really just want the wind speed, that first element there. So let's pop back into here. Excuse me. All right. So in order to do that, in order to compute power, equation for doing that looks something like this. 1/2 rho, that's air density, velocity cubed times a rotor times crap, it's 53%, 57%. Shoot, I'm forgetting it out of hand. Hold on. $59.3, great. Times 0.593. That's equal to power out. All right. Wow, that really does look creepy. Anyhow, so that's the equation that I need to run. I can get wind speed from the file. That's easy enough. I can set air density. I can set rotor area. That's all easy stuff. I can just do that. Great. Does someone need this up anymore, or you all got it somewhere? Cool. There's at least one person that said didn't need it. So there we go. Mouse. All right. So Let's jump back into here. Let's just define a couple of variables. Air density, 2.225, that's in kilograms per meter cubed. So data is in meters per second. A rotor, say this is a 45 meter long rotor per blade, so that's pi times 45 squared. Ordinarily, I'd set, I'll just set it here. Better than hard coding it. All right, so we got everything there. Just need to extract wind speed. You know that wind speed is always in the first element, so it always has an array address of 0. We also know that we're extracting data from a string, right? So that means the data we extract from a string is still a string. So what do we have to do with it before we do math on it? I can change it to an integer, or because it looked like if I look back at my data here, I have at least one that's not an integer, right? So it has a decimal. So what do I want to change it? What data type do I want to convert it to? What data type can take not having, or sorry, what data type can take a decimal place? A float, right. So I want to convert my string to a float. So float, that, done. All right. And then I can just do my equation, 0.5 times rho times wind speed cubed. Just going to put that into parentheses because I'm paranoid, times a rotor times 0.593, I think it was. 8? No, one second. Welcome. And I'll print that out. I know that's in watts. So I convert it. So I grab a row, I split it, I grab data out of it, I convert that data to a float, I do math on it, then I use my answer in some way, shape, or form. Cool. So let's try using that. Well, that's not good. What the heck? What's it saying? Right. And the string that's trying to convert to a float is a word. So that's fair. I couldn't convert that to a number either. So let's have a look at where our data is coming from. So source, that's this very first guy here. How do I avoid asking my code to convert that to a float? Because I don't want that as a float. How do I make it not try? Bring back up my code here. how do I make it ignore lines 1 and 2? Because 2, I'm probably going to run into the same problem on. Yeah. Mm-hmm. Okay. So if a character inside of my string is something that's not a number, skip it. Is that what you're trying to say? Yeah, you totally could do that. That'd be a great that'd be a great way to do it. So I could, instead of putting it there, I could look at row data and ask, is that a 0? Is that a 1? So on and so forth. But conveniently, we have a much easier way out of it this time. Moral of the story, checking to see if the user's done something dumb is hard. Checking to see if they've put an input file together correctly, that's a lot easier. We don't care about the first 2 lines. We know that is true. It will always be true. Therefore, we can just skip the first 2 lines if you had some way to count lines. So the same way as in the binary problem, we made a counter just to count how many loops of the how many times we've gone through the loop. And just say counter equals 0. And in my loop, I'll just say counter equals counter plus 1. So the first time through the loop, it'll be 1. Second time through the loop, it'll be 2. Both those times, I don't care about doing anything. I just want to skip it all. So I'm going to ask if counter is greater than 2, do all this. Implicitly, if it's less than or equal to 2, skip everything that's in the if statement. Let's give that a shot. There we go. That's more like what we're looking for. Oh, sorry. Any questions on that logic? Cool. Right, so everything tabbed in under the if statement is part of the if statement. So I'm saying that if I've gone through this loop more than two times, because that's what counter is counting, for lack of a better word. Extract data extract a string from my data. If I haven't done that, I don't care what's there. Move on. That's essentially what that if statement says. Any questions? Great. All right. In that case, that's all I wanted to show you about that. Again, the idea is just it's a more flexible way to get input. So if you're trying to bring in, like for your final project, say a table of material properties as well as a couple other data points, this can be a lot easier way to do it than numpy load text. Something to, while we're thinking about that, are there any questions about the final project? Has anyone looked at it? Okay, if you haven't, it's fine. Keep in mind, 5.5 more weeks of the semester. Kind of nuts. It's coming up fast. Say again? Not sorry. Until final this week starts. So so probably 6 weeks until the project's due ish. So I'm going to go over the math part of it one more time, namely next Monday. But just keep in mind that it's coming up soon. The only thing we have not gone over that you need for the very last part of it is how to plot things using Matplotlib. But that's the only part that we haven't gone over yet. You in theory right now could make the entire numerical method and everything else you need in order to get the value of the Z factor. Speaking of homework though, the homework that'll be out today, due next Monday, is instead of a binary conversion, it's going to ask you to do a hexadecimal conversion. So I just want to make sure we're on the same page as to what hexadecimal is, besides being a really cool nerd thing, which it totally is. So hex. See if I'm cool enough to do this. Apparently I'm not cool enough to do this. There we go. Whiteboard. Okay. So there you go. So hex is so if binary is base 2, hex is base 16. So cool. So what does that? So what does that mean? It means that if I had a number, first place is, whoops, not 0. First place is 16 to the 0 power. Then it's 16 to the first power, 16 to the second power, third power, fourth power, so on and so forth. So the logic in terms of how you determine what the base 10 equivalent is still the same. I have 0 ones, I have 2 16s, I have 1 256. Fortunately, I'm not as cool with my powers as 16. I have 3 16 cubeds, and I have 8 16 to the fourths. And if I added all that up, that'd be my base 10 value. Cool beans? All right. The only thing that is weird about hexadecimal is that, well, if this first place goes up to 16, I need to be able to put up to 16 in that one place, right? But I can't because it's one place. So what hexadecimal does is cheat. So if I was to write out in the ones place all the values from 1 to 15, all in, here's the base 10 thing, here's value in hex. And let's get a couple columns going. Oopsie, come back here. There we go. So 1 is 1, 2 is 2, so on and so forth. 9 is 9. All those are the same. It gets strange when we get into the large numbers. So 10, that's the first one I need to squeeze into one digit. That's an A. 11B, 12C, 13D, 14E, 15F. So if I want to say 15 in hexadecimal, I say F. What if I want to say 12 in hexadecimal? I say C. If I want to say 26 in hexadecimal, oopsie, come back here. Well, if I want to say 26, well, that's what? That's 116 plus a 10. So it'd be 1A. I have 10 ones plus 116. Yeah? Cool. If I want to say 141, okay, hang on. I'm gonna have to break out a break out a calculator for this to make sure I don't screw it up. I did it last night, but just make sure. Yeah, that's 8 16s plus 13. Yeah. So 8 times 16 is like 120. 129, 128, and then plus 13 gives me 141. We all see the logic here? Great. It's pretty much the same thing as converting in binary, except your place values can be different. They can include letters as well. So your mission, whether you choose to accept it, in your homework assignment is to make a hexadecimal converter. So in addition to doing the place value stuff, you're also going to have to convert letters and stuff as well into base 10 values. But should be fun. All right. Any questions? All right, that's all I got for today. We did kind of a twofer today. So this was also Friday's lesson, kind of all in one. So Friday is a work day. It's what we would have done for longer today, pretty much. You can use Friday to work on homework, final project, whatever. Cool beans. Yeah. Next Monday. Cool. In that case, the rest of the time is yours.